This work is a fun case study that came about through conversations with Laura Neal. Laura is a research assistant I'm working with who is hopefully going to become a PhD student very soon, and also work done with William He, who's a research engineer with us at QUT in the Generative AI Lab. He's here today. Bad maps. So this is about the challenges of doing ethical navigation at scale. So I'm sure we've all interacted with Google Maps. Is my clicker going to work? Next slide, please. Google Maps, a app that many of us are familiar with. It's used by more than 1 billion people per month and operates in over 220 countries, has 77 different languages. It's pretty incredible. You can travel halfway around the world and pull this app out, and most of the time it works pretty well. One of the features that Google Maps has is navigation guidance, where you type in your destination and it tells you how to get there. But this case study sort of demonstrates that when you try to do this kind of automation at a really big scale with many, many users, there's unique challenges that arise. And it's interesting to sort of look at and explore that. Next slide, please. So last year, Google Maps disclosed how this system that they use for their navigation guidance works under the hood. And what they use is something called maximum entropy inverse reinforcement learning. Incidentally, this is what I did my PhD on. But what this means is when you ask to go to a destination, under the hood, what's happening is, next slide, please. Thank you. The app is using something called a maximum entropy model. So this is a probability model. It sort of looks at possible routes to get to your destination, and it picks them based on this equation. So don't get afraid, it's a bit of math here. If you look at the color scheme, though, what this is saying is the probability of choosing a road segment, which is the tau, the little Greek letter T, is exponentially proportional to something called the reward that's associated with that road segment. Next slide, please. And so this idea of reward, this is like a scalar value that says, okay, going on this road is this good versus going on another road segment is less good or more bad, like it's a scalar number from positive something to negative something. And what happens when you put together this sort of model? So it's doing this sort of prediction task for individual app users, right? It doesn't have a global picture of what's happening for many different users using the app in an area of the road network at a given time. If we go to the next slide, what this leads to is actually queue jumping recommendations. And so this is something that I've observed in my own use of the app over the past 6 months, and possibly related to an update that happened in the app maybe 8 months ago. But what you see in each of these screenshots that I was able to grab is me navigating somewhere on a highway, for example, and then there's congestion on the road ahead of me, right? So this is one of the features that the model uses to predict how good or bad a given road segment is. And this data is being crowdsourced from a bunch of different third-party providers and other apps, including Google Maps users, on the road ahead of you. And when this congestion appears, if there's an alternate route, like a slip lane that goes down the side of the highway, Google Maps is actually recommending that you divert yourself off the road, go down that slip lane, jump several hundred cars, then jump back in front of the queue, right? This is obviously good for the individual driver. It saves you maybe 5 minutes, 10 minutes sitting in queued traffic. But I would argue this is unethical. It's actually also proven to be suboptimal for the road network as a whole. There's lots of agent and simulation-based studies that show that this kind of queue jumping actually slows down traffic for everyone on whole, because the merging back at the merge point then sort of slows down the traffic and perpetuates the traffic jam. And it's also illegal in some jurisdictions, like in certain municipalities in China, for example. This is actually illegal behavior as well. If we go to the next slide, please. And so this kind of feedback loop where you have local features about a road coming from like a crowdsourced data set, for example, and then you're not capturing this feedback effect where drivers merging back in later in the road network is actually causing and perpetuating this traffic for everyone else on the network. That's an example of a type of thing called exogenous feedback. And so I've written about this in another paper with some other co-authors. It's basically feedback that is not captured in your assumptions about the way you're automating this part of a system. And so there's technical approaches that you could possibly take to mitigate this. So maybe you could try and do more global optimization. You could consider navigation for multiple users at once rather than one car, for example, or look at how you construct the features for this reward model when you're doing navigation a little bit differently. More generally, though, I think socio-technical specification is a term I've written about in another paper, which is a more robust approach to sort of think holistically about these kinds of systems and about optimization at scale like this, and actually sort of approach it more holistically that I think more robustly addresses these kind of issues. And if you're interested in that, there's a paper where I've written much more about that. Next slide, please. Interestingly, Google Maps is interested in exploring how to enhance the ethical navigation properties of their Google Maps offering. So recently, since actually submitting this abstract to the symposium, they released a feature called the Eco Navigation option, which you've probably seen as the little green leaf when you're navigating, that now, by default, I think, it tries to choose low fuel consumption options for your route as you're driving. And so they're obviously open to this sort of I won't call it greenwashing, but this sort of signaling and virtue signaling and exploring ways to enhance the sort of ethical aspects of their navigation product. Next slide. Thank you. And there's some references there, but I'd love to talk to you more about this in the poster session afterwards. Thank you very much.